within the series, we will be discussing the basics of Pandas series object, and we will also learn about some series operations. And within the data frames, we will be discussing about some basic data frame operations and also manipulate the columns as well as rows in data frame. Before we start implementing the series in Pandas, we have to import Numpy and Pandas. So I am importing it, Numpy as NP and Pandas as PD. Now if you go to the help of this pd.series, you will realize that you have lot of things within series that you can do, and you can also read about more what are the applications that you can do using this series. So within the series documentation, you have few things which are available to you. So if you go through this, you will understand that lots of things are there. So it is better if you can do it yourself. So now within the Panda series, you have many arguments that you can use. So what you can do is you can also give the data. For now, I am giving this as none because we don't want anything for now. But these are some of the arguments that you can utilize for yourself. Only these two are the main in which you will be giving the input as the data, as well as you have to tell the index. So whatever the index is, you have to mention. So let's do it. So let's for now define two lists with the name of my index and my data. So these are the names of the countries and these are the years in which they got the independence. So now if I want to convert these lists into series, what I have to do is I have to give my series as pd.series data equal to my data. Notice that I have not defined any index here. So let's see how it works. I'm just giving the data. So it is only picking this second list and these are the values. Notice that these data types are int64. These values are the integers. Now, if I want to look into this type of my series, so because this my series is a series object, so it will give the output as series. Okay, so it is a Panda series. Okay, now if I want to give the index also along with that, I can give it as data equal to my data and index equal to my index. So my index will be picked from here. So these are the two arguments which I am giving into the pd.series. And if I run this now, you will notice that these 0, 1, 2, which were the initial indexes, have been replaced by India, USA, and Canada, right? So these are the new indexes. Now, if I want to get the value out of this series, I have to give that I want to get the India value or the USA value instead of 0, 1, 2. Now, if I print this now, my series 0 and my series India, what will be the output? Any guesses? So if I do this, both the outputs will be same as 1947. So it's not that my series 0 will not work. It will also work. By default, this India is at the index 0 only. So it will also work. But this my series India will also work. And these both have the same functionalities. They are both giving the output as 1947. Let's do it with for a dictionary. Now let's do it for a dictionary. Jersey equal to, these are the uh, keys and the values, right? So Rohit is the key, Virat is the key, and UV is the key. And these are the jersey numbers 45, 18, and 12. These are the values of those keys. Now, if I convert that into a series, now this will be like this. So Rohit, Virat, and UV are the three indexes, and 45, 18, and 12 are the values. So these keys have been converted into indexes by just doing this pd.series of this Jersey dictionary. I hope that you know this is a dictionary of key and value pair. Now let's do some basic series operations. So let's say that these are the two dictionaries in which match 1 is equal to Rohit, Suryakumar Yadav, Pollard, and Ishan. So these are the four players of Mumbai Indians. And let's say that they scored 80 runs, 68 runs, 90 runs, and 45 runs respectively in match 1. And similarly in match 2 they scored a century for Rohit and 80 runs for Suryakumar Yadav, 20 runs for Pollard, and Ishan scores 60 runs. So let's say that these are the two dictionaries. Okay. Now, if I want to convert these two dictionaries, I can convert it by using this pd.series, and these two will be series now as series M1 and series M2. If I print them, they will be printing the values in these formats. You can see that these are working similar to the previous ones. So Rohit, Sky, Pollard, and Ishan are the four indexes here, and 80, 68, 90, and 45 are the values. Similarly for series M2. Now, if I want to get the value of Rohit in match 1, so I can simply do series M1 and Rohit, right? So it will give me 80 runs. So this is 80. And similarly, if I do it with zero value, it will again give me the same value, obviously. Now, if I do this, if I want to run this with R small, now notice that this is R small, and within the series M1, I have this R capital. So it will throw an error that Rohit is not there. With R small, this Rohit is not available in it. Key error is Rohit. So it has to be same as capital letter that was in the series M1 by default. Now, to make sure that you do not do a mistake like this, what you can do is you can print the series M1's keys. So this keys will be Rohit, Sky, Pollard, and Ishan. So all the four names are there. These are the indexes. These are the actually key values within those series that have been taken from the dictionary. So these are the four keys, right? And only these four words will be accessible to us, and this technique can help us reduce the errors of spelling mistakes in terms of lower and uppercase. So let's do a broadcasting operation now. So if I do this now, that 1 comma 2 is a list and I want to multiply it by 2 using the broadcast function. So if I do it as a multiplication of 2, what it will do is it will give me a duplicate copy of 1 comma 2. It will not actually do any operation within those values. It is just making a copy of this list into twice the size. And if I want to do some broadcasting operation, what I have to do is I have to first convert it into np.array, the numpy array. And if once I get this list into numpy array and then I do the multiplication, then the actually multiplication will be done for the each value within that array. So the answer will be 2 and 4. Similarly, if I want to do this for my series, so series m1 into 2 divided by 10 will be this. So all the players values have been divided by 10. After multiplication by 2, they have been divided by 10. So you can actually manipulate the values within the series just like the way you did in the numpy array. Okay, now if you want to check again the series m1 values, you will see that they are unaffected. The original values are same. Why? Because we did not assign this into the series m1. It is just that we are getting the values on those. We are just doing the operation, but we are not saving it into the original series. So the original series is similar to the actual value. So now let's say that I append these two values in the series m1 and series m2. So Bumrah and Pandya have been added. Now if I want to print this both the series, so you will see that in series 1 this Pandya value has been appended, and in series 2 the Bumrah value has been appended. Now what if I do a plus for both the series? What will be the output according to you? Will it add both the values for everyone? And obviously this Pandya is not having a copy in this second series. So what it will do is it will give a not a number value for both the names in which the second value was not found. So Bumrah and Pandya has not a number, and all the other players are having this addition value to the numbers. Now notice that because we have done this plus operation, the value which was data type int 64 has been converted into float 64. So notice this thing. Now let's say that you want to do this operation and you want to get the values. Let's say that even if Bumrah was not there in this first list, We just want that Bumrah scored total 10 runs in 2 matches. Let's say his batting didn't come in the first match, or Pandya's batting did not come in the second match. So we just want to get that how many runs were scored by the players in 2 matches. Now that can happen that one player has not played a second match, but still the total run should be reflected. It should not be not a number the way it was giving, right? So what you can do is you have to use this add operation. So we are doing this operation op equal to series m1 dot add. So we are adding this two series by using this dot add function, and we are filling the value equal to 0 in case it is not there in the other list. So Pandya was not there in the second list, but so because now we have used this fill value equal to 0, it will consider 0 value for Pandya um, for the second match. So it will actually give the total runs scored by all the players in 2 matches. So Bumrah scored 10 runs because he batted only once. Pandya scored only once, so 40 runs for him. And all the other players got batting twice, so the total runs have been added. So this is how we skip this not a number thing. Now, if I want to see the data type of this series, so it will be in 64. Now why? Because original series was having the values as the integers, but because we were doing the operation, by doing the operation we got the value as float 64, and this operation has not affected the original series data type. Okay, but now op.data type will give me float 64. Why? Because within this op we got the values as floating numbers, and it is float 64 now. Now coming to the data frames, so let's talk about data frames now. So np.random.seed, so what I am doing is I am just generating 3 4 of an array. All the values will be random within the range of 0 101, and using the seed value we will make sure that I and you are getting the same set of 3 4 values. Now if I run this, I will get a array. It is a 2D array. You can notice that there are two brackets. So it is a 2D array with 3 rows and 4 columns. Now let's say that I want to name my indexes and my columns as Mumbai, Delhi, Hyderabad, and Jan, Feb, March, April. So if I run this now, and now what I want to do is, I hope that you have guessed it already. I just want to give this first row the index of Mumbai, and I want to give this 8 as the column name as Jan. 24 column should have the name as Feb. So I want those things. Now data frame will help us to do that. Now what I have to do is now, so if I do this pd.data frame my data, I'm I'm only using this my data for now. I'm not involving my index in my column. So what it will do is it will convert my array into this beautifully represented 0 1 2 3 as the 4 columns and 0 1 2 as the 3 rows. Now notice that this is not a column heading. Here there is no column heading for the 0 1 2. So these are the indexes in itself. It does not have a column heading. So you might be not knowing this, so I mentioned that. Now let's say that pd.data frame data equal to my data, index equal to my index. Now what I have done is, now we know that my data, if I pass this my data value in this data frame, it will give me values like this. What if I give this index also as my index? So now Mumbai, Delhi, and Hyderabad will be given as the 3 indexes in place of the 0 1 2 at the row location. So Mumbai, Delhi, Hyderabad is there. Now if I also give the column headings, so it will also update the 0 1 2 3 at the column heading level, and it will be Jan, Feb, March, April, and Mumbai, Delhi, Hyderabad. So this is how we make our own data frame by using the random values, and maybe you can have other values also. But now I have also shown you that how to name your rows and columns. Now if I do the data df.info, it will give me all the details that how many columns are there, what are their names, so if there any non-null values are there or null values are there, so all things will be given. And even the memory is provided that all the data types were integers, and accordingly you can calculate the byte size, that how much memory is being used in bytes or kilobytes. Now if I want to read a file, uh, let's say that you want to use this function pd.read, and then let's see that what are my options that what type of files I can read. Now there are multiple options for us. We can read a clipboard file, CSV file, Excel, Feather, so HDF, JSON file, pickle file. It is a machine learning model file. So pickle, and then SPSS SQL. So even SQL tables and SQL queries can be read. Even the SQL can be handled easily using Pandas. So it is that powerful. And also we will be learning about how to deal with the SQL dataset in the coming videos. But for now, I will be discussing only the CSV value. So let's comment this. Now let's say that I want to read a CSV file, but before that, I want to tell you that I am using this dataset, Iris dataset on Kaggle. So this is the Iris dataset. Okay, so if you go to the data here, and there is this CSV file here, and you can download this using this download button here, and the file will be downloaded for you. Now let's say that I want to know that what is my present working directory. So within the collab, what I have to do is I have to put a exclamatory sign before the command, the way you were doing for, let's say, command prompt, but we are just appending exclamatory mark before the command. So present working directory is content. So if I go to this file section on the left hand side, so this folder is content. Okay, and now if I want to put my CSV file into this location, uh, we will do that. But before that, I want to show you that within this present working directory, which is content, what are the different files available to us. So ls is the list command. So within this, sample data is the only folder which is there, and CSV file is not there. So I want to use this iris.csv file, but it is not there yet. So what I have to do is I have to go to this file menu, and I have to drag and drop my CSV file here. So let me drag and drop it and add the CSV file at this location. So I have dragged and dropped this iris.csv file, and you can do the same. So now if I run this list command again, it will show me that iris.csv file is available. Now if I run this command pd.read.csv, and iris.csv file is read into the data frame. So if I run this now, it will give me the data frame as this data set values. So there are 6 columns ranging from id to sepal length cm, sepal width centimeter, the petal length cm, petal width cm, and the species. So there are 3 types of flowers in iris: Setosa, Virginica, and one more. You can look into that later on. But for now, what I will do is let's see that how it works. So let's do some basic operations on it. Now we have the data frame, we know that how it works. The columns and rows are there for us now, but I want to just get the names of all the columns. So if I do this df.columns, it will give me all the 6 names here. Okay, and if I do this df.index, it will give me that it is a range from 0 to 150. So there were total 150 rows, if you have noticed, and the step size was 1. So it was ranging from 0, 1, 2, 3. So there was step size of 1. Now if I run this df.head, it will give me top 5 rows of that data set, just to give me the insight into how many columns are there and how does the data look. Now if I want to get more or less head values, I can edit that value and put a 10 inside my head function as an argument. So what you can do is you can run it like this, and you will see that there are 0 to 9, total 10 rows being available now. So you can get the head value in this manner. Same you can do for the tail. You can get the last 5 rows by default, and also you can get the tail value for more or less values depending upon what is the value you are passing in this. So now if I use this df.info function, you will notice that this is the detailed version of what are the values and how many types of things are available to us. You will notice that this sepal length, sepal width, petal length, and petal width are floating numbers. This id was my integer value, species was an object value. So these are the things available to us if we analyze this information. Now if I do this describe, so if I want to uh, know that what is the mean of this data, what is the 25 percentile, what is the 50 percentile, so all those kind of things. So if I run this df.describe, I will get those for all the values, for all the columns having integer or floating values, not for the strings. So the count, total count is 150 for each column. The mean values are given, the standard deviation, min value, max value, the 25% and 50%. So all those kind of values are there which are available to us. Now let's do some column operations within the data frame. So if I run this df.head, you will see that there are these 6 columns. Now if I want to know that what is the data type of my petal length cm column, so I can run this command type df petal length cm. Okay, so this is a series. Obviously it is a series, multiple series are joined and we say that it is a data frame. So this is a series, this single column is a series for us. Now if I want to use that only some columns are selected, so I want to select these 2 columns, I can do it like this: my columns equal to this list of columns, and if I pass that into my data frame as my calls, so I will get this data frame which is my calls. So all the values are there for only 2 columns from 0 to 149, total 150 rows. Okay, now same can be done if I want, if I pass this list as it is instead of using this my calls variable and in fact my calls list. So if I pass this list as it is, you notice that you should notice that there are 2 brackets here, so we are passing this list as it is. So if I do this now, I will get the same result. Okay, so there are 2 methods to do the same thing. Now if I want to do this, I want to, let's say, generate a new column with the name petal sum cm, and I want to add the values of petal length cm and petal width cm. So what we can do is we can calculate the values, and if you print that, what you will notice is you will get the values as it is, petal sum cm. So if you print that, you will get the values, that all the values have been added. Now you want to put those values into a data frame and append that into the data set. So what you can do is you can actually do this thing. So after getting the values, you can assign that value as a data frame column. So this is a new column. Notice that petal sum cm was not there initially. It was only the id and then the petal length, petal width, sepal width, and the species. So petal sum cm was not there. Now this will be appended into the data frame, but also notice that if you use the previously available name of the column, that column values will be replaced instead of getting the values appended, so the full column will be replaced. So now if you watch the head value, you will see that this column has been appended in the end after the species. Now if you want to drop it, what you have to do is you have to you have to use this command df.drop petal sum cm, but also you have to tell that this is the axis. X is equal to 1 means you want to drop a full column. If you want to do it, if you wanted to do it for rows, you could have written x is equal to 0, but for now we are using x is equal to 1. So if I run this, so this is how it looks. So this petal sum cm is dropped for now, but if you watch this, if you want to look into the data frame again, you will notice that it is not deleted yet, so it is still there. So what is the mistake? We have not replaced our data frame with the updated value. We have just seen that how it looks like after doing this operation, but we have not replaced it. So how can we replace it? We can do it by using this df.drop and also assigning this value to the data frame. So it will help me drop it from the data frame. Now notice that I did not mention it here earlier, but you have to do this one thing. Let's say that I will run this thing again. I will assign this value again. So I want to show you that without the access value there will be error. So what will be that error? I want to discuss about that. So this says that petal sum not found in access. Now by default x is equal to 0 is taken, and x is equal to 1 has to be mentioned. So now we have to give this x is equal to 1 by default. Okay, if you want to work on a column, you have to give x is equal to 1. It is expecting the x is equal to 1. So if petal sum cm would have been a row, let's say this 0 would have been petal sum cm, then it would not have given any error in this dot drop function. But because we want to do it for a column, that's why it is giving error like this. So what I will do is I will run these 2 3 statements again. So now some might be wondering that why x is equal to 1 is column, because if you do this df dot shape, you will notice that it has 150,6 values, in which 150 are the rows and 6 is the column. So that's why 0 location as the row and 6 is the location 1. That's why x is equal to 1 is column. Now let's do this rows in data frame operations. So how do we handle the rows in data frame? This is the last section, and then that's all for this video. But for now we have to learn that how does rows are manipulated in a data frame. So if you see that df dot index, now if you see what is the value of df dot index, it will give me that it has a range of 0 to 150. Obviously the values are from 0 to 149. Total values are 150 and step size is 1. Now if you want to uh, do this df dot set index id, now what does this do? It does column id is now index id. Let's see what does this mean. It means that we had that one column id in the beginning, and then we had this sepal length, sepal width, and other columns. Now we have converted that id, which was a column, into the index, uh, into the index value. So this id will be counted as an index, and these 1 2 3 4, all the values that were in that column are now index values. And we have only 5 columns now. So if you see the size, it is now 150 cross 5, not 150 cross 6. Now let's say that we got this. Now let's say that we got this id value like this. And now what we want to do is we want to get this id index as back to column. Now it can be done by simply doing this reset index. It will bring back all the columns back. And if you want to look into it, you will see that again this id is back to being a column. Now let's say that I want to use this as an index, so I will do that again. So now I want to get the row based on a integer location. So I can do this tf.ilog, which is integer location at 0. So it will give me the first row out of the full data set. So it is giving me all the values which were there in the first row. All the values are there, and even the species is there. So this is the first row. Okay, the name was 1 because name means this id. This is the name. It can be a string also. If you had written your name here, let's say I write this one as Sahil, so it will give me that this name of the row is Sahil instead of 1. So it can be a string. And now again, if you do that based on the location, it works on a string also. So actually it works on string only, but in this case we have id as numbers only, and these numbers are actually strings if you look into the detail. So what we will do is df.loc1. So this also gave me the same value which was given by log 0. Exact same values have been given by loc1. Now, if I want to grab the multiple rows, this slicing can also work. I lock 0 to 3, it will give me 0, 1, 2, the first 3 rows. And obviously 0, 1, 2 means this id equal to 1, id equal to 2, and id equal to 3. And similarly, if I want to do this, that I want to get it based on the id values exactly. If it is, now in this case it is 1 2 3, but it might have been abc also, so it can also work in that case. So df.loc123 means that I am passing a list of all the names of all the ids, and if I run this now again, same output will be given, right? Exactly same output is there. Now if I want to remove the first row, what I have to do is I have to do this df.drop, and I want to remove this thing. I want to remove this id equal to 1 row. So I have to do this df.drop 1, which is being treated as the name of that row, and x is equal to 0 means that I want to remove this row. So if you do that, you will see that the full data set is there, but this id1 is gone, right? But obviously it will not reflect in the original data set because we have not done this df equal to df.drop, but we have only done the operation. Now instead of dropping one row, what we can do is we can also do this by selection. Selection means that I want to get all the rows starting from index 1 till the end. So it means that it will not pick the 0th index, so it is again giving me the same output starting from 2 till 150. Now, if I want to get only one row out of it, what I can do is I can assign that df.ilog0 as one row, and I will get this first row as it is. If I want to append that to my data frame, it will be appended to the end, and you will see that this one ID, all these values are there in the end also. So this has been appended here, right? Now if you want to delete the duplicate row, now because we have this duplicate row and this is also duplicate row, so these are the two rows which are doing duplicacy of each other, so we want to remove one of them. So I can use this command df.drop duplicates, and I can print that. Now I want you to know one last thing, that if you use this command, it might be the case that there are few other rows also in which the values are exactly same. Let's say that this row 4.6, 3.1, 1.5, and 0.2 are isitosa. So let's say that this row has maybe 4 copies. There are multiple copies of it within the data set. So even those will be removed. The duplicates will work for that case also. So if I run this command, you will see that instead of 151 rows, it is now having only 147 rows. It means that not only that one in the end was removed, but other 3 rows which were duplicate of each other were also removed. Yeah, so that's all in this video. We have learned about the basics of a series. We have also discussed about the data frames and all the operations related to that. We will learn about the more advanced operations in the coming videos. So subscribe to the channel to watch more of them and learn more. I hope this video was helpful for you, and let's meet in the next video. Thank you.